Bienvenidos, Ushamdi, and welcome, CTS230, Section 841 students, for the first 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 3 course, or the Cisco Networking Academy Scaling Networks V6 course, and this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 3.3.2.2, where we're going to build upon the activity 3.3.1.5, but now instead of configuring per VLAN spanning tree plus or PVST plus, we're going to be working with RPVST plus. In other words, we're going to be doing Cisco's implementation and adaptation of the standard rapid spanning tree protocol, which again is referred to as RPVST plus, and sometimes you'll see it as per VLAN rapid spanning tree, which is PVRST plus. And I'll again talk about that plus sign, meaning that we're using .1Q, 802.1Q encapsulation. So let's go ahead and dive in here and take a look at the activity that we're going to be working with. And again, you can see very, very similar to the previous activity, but instead of one PC or one in node on each of the switches, we have all three PCs, PC 1, 2, and 3. They are all on the same switch, which is down here, switch number 2. So let's go ahead and take a look. Again, we're going to be creating, and the activity is very, very similar. It's just the location of the PCs has changed. So again, similar but not the same, and we're going to call out the differences between rapid spanning tree, or RPVS, I'll just say RPVST plus from here on out, and PVST plus. All right, so first thing to do here, we're going to enable the user ports on switch 2 in access mode. Again, the text is going to be awfully tiny here, and so I will definitely be sure to sort of MC the commands that are being run. So we're in user exec, as is witnessed by that greater than sign after the host name, which is just S2 for switch 2. We're going to type enable to get into privilege exec, and then configure terminal to get into global configuration mode. And so again, we're on switch 2, and we have 3 ports here that it's asking us to go ahead and issue the no shutdown command on. So what I could do is go into each port individually. However, let's save ourselves some time with that interface range command. And I'm going to say fast Ethernet 06, comma, fast Ethernet 011, comma, fast Ethernet 018. And did I leave out the comma? I put a slash, I apologize there. So there we go. So interface range, fast Ethernet 06, 11, and 18. And then we're going to simply issue the no shut command. Now you can see, remember, we're going to have to, we just took these ports from what's referred to in legacy original 802.1d spanning tree. Remember we have the 5 states that we're talking about here, and let me grab the pin tool. So in the legacy spanning tree, which I'm assuming that's what these switches are running, remember we have disabled mode, I'll just put DIS for disabled. We've got blocking, and this is what we see on a non-designated port. We've got listening and learning, and then finally we've got forwarding, which is the state that we're trying to get to because we want to be forwarding data frames, right? So it was no shut. Well, if it's no shut, it means that we are disabled. So as soon as we take it from the no shut, as soon as we take it from being shut down, issuing the no shut command and bringing the port up, you'll notice that these guys were orange here, and that's because they transition into the listening state. And so they're going to be in that listening state for 15 seconds. And remember when we ran that command, show spanning tree root, we saw the different times there. We saw the Bpdu hello time, by default 2 seconds. We saw the max age timer, which is, again, think of it as kind of like a dead timer. Like if I don't get 10 BPDUs in a row at 2 seconds a pop, then something's obviously wrong. I'm going to declare myself to be the root bridge, and we're going to go ahead and relearn things. And that's the learning here, which is kind of cramped together there, but that's learning. And again, you've got another 15 seconds here, right? So that's that forwarding delay that we talk about It's the 15 seconds in listening, the 15 seconds in learning, and then we go to forwarding, which results in the green ports coming on. And so this is why I typically say, you know, anywhere from 30 to 45, 50 seconds. When you're plugging the PC in, and if it's disabled, we bring it on board, we're looking at about 30 seconds. If we have some sort of a spanning tree event, remember, we've got that max age timer of 20 seconds. And so this is where I'm getting that number that I'm throwing out, right? So we bring the port online. It's a host port. We're going to be waiting at least 30 seconds for the transition to take place, right? Because we haven't said spanning tree portfast on any of those ports. And so that's what portfast does. It skips listening and it skips learning, right? So we don't have to wait for these timers, and the port transitions to forwarding immediately. When we talk about that max age timer, that's more of a, and that's supposed to be 20 seconds. The max age timer is for more of an event that would happen between switches, right? Some sort of a transmission medium problem where the BPDUs are being lost for whatever reason. And that's where we get that 20 seconds. So 30 seconds for the host, a spanning tree event somewhere in our topology could run us with an additional 20 seconds. And again, that's assuming that the max age timer hasn't been, you know, it's not at like 15 seconds or whatever. So I'm just going to assume the maximum value. So 30 and 20 is that 50 seconds that I keep mentioning. And so the port is now online. You can see we've even been rewarded here with 3 points down in the lower right-hand corner. So let's go ahead and transition back to the activity, keeping in mind that, and let me go ahead and say, do show spanning tree summary, and let's confirm. Yeah, so switch is in PVST mode, per VLAN spanning tree mode, which again is the Cisco, if I were to say do show span, you can see here it says spanning tree enabled protocol IEEE. And if I believe the diagram is, this work from the other day is still up here. So not going to hash this whole thing out again here, but again, keep in mind that the PVST and the PVST plus, right, these are how Cisco refers to their adaptation of the 802.1d, original 802.1d 1998 standard, right? Now remember, we talked about this in the 3315 video, that the original spanning tree protocol is not even referenced anymore, right? It is no longer, it's legacy, it's deprecated, should not be used. And you'll see that if you ever look at the 802.1d 2004 IEEE standard. So again, this is legacy and it's default on a lot of the older Cisco hardware. Again, on the newer hardware, the newer 3850s, the newer 3650s, the default is rapid per VLAN spanning tree plus, right? Because ISL, just like legacy spanning tree, Cisco's proprietary trunking encapsulation protocol, ISL, is no longer implemented in the newer code. It's gone. It's not even an option from which you can choose. All right, so we've enabled the ports, create the VLANs. Again, this is going to be, I'll call it heavy lifting. Maybe repetitive lifting is a better term. So typically, one more time, you would say VLAN 10, 20, 30. Unfortunately, Packet Tracer doesn't like that. So it's good muscle memory, it's good repetition to get in the habit of saying I need to create some VLAN. So we're going to say VLAN 10, VLAN 20, VLAN 30, VLAN 40, albeit very repetitious, VLAN 50, VLAN 60, VLAN 70, VLAN 80, VLAN 99, those same VLANs that we had created in the previous activities. Now we're going to come over here to switch 1. We'll come to the CLI for switch 1. We'll move that down here just a skosh. All right, and there we are on switch 1. And from user exec mode with the greater than sign, we go to privilege exec with the enable command. Configure terminal is putting us in global config. And here we've just got VLANs, right? VLAN 10, VLAN 20, VLAN 30. If I wanted to name these after I say VLAN number, right? VLAN 30, I could say name engineering, but we're just going to go ahead and say VLAN 40. VLAN 50, VLAN 60, VLAN 70, VLAN 80, and VLAN 99. And did I say 99 on when I did switch 2? Yeah, okay, we did. All right, now over to switch 3 for our final pass here with the VLANs. And we go from user exec to privilege exec with the enable command, configure terminal, puts us in global config, VLAN 10, VLAN 20, VLAN 30, VLAN 40, VLAN, whoops, sorry, misspelt that, VLAN 40, VLAN 50, VLAN 60, VLAN 70, VLAN 80, and VLAN 99. All right, so we've got all of the VLANs created here. Let's now go ahead and it says assign VLANs to switch ports, right? So if we take a look up here, it's all going to be done on switch 2, right? So instead of hopping around, we get to do everything right here on switch 2. So start with interface fast Ethernet 06. We're just going to work from top to bottom. So now we're in interface subconfiguration mode, and we know these are access ports, and we're assigning them to a single VLAN. So we're going to say switch port mode access, switch port access, VLAN 30. Right now, you can probably guess that toward the end of this activity, yeah, we're going to be configuring portfast and Bpdu Guard. So why not do that right now, right? So I'm going to say spanning tree portfast, and again, we're going to be skipping the listening and learning states. And when I say listening and learning, I'm referring to, remember, I'm still referring to legacy 802.1d, the original version of spanning tree. When we talk about the rapid spanning tree protocol upon which RPVST plus is based, we've got some different states, but I'll come back to that in just a second. So again, we're going to be transitioning from down or disabled, and discarding is the term used with RSTP or RPVST plus. Discarding, we're going to go straight to the forwarding state, which means we're going to be skipping the learning state in RPVST plus, or what is rapid spanning tree protocol, the standard, right? So let's go ahead and say spanning tree Bpdu Guard enable. And remember what that means. Since we're skipping the listening and learning, or with RSTP, RPVST plus, we're skipping the learning state, we need to go ahead and make sure we protect ourselves from accidentally somebody plugging a switch into this port. Upon reception of a BPDU, it will error disable the port. And so let me pause here real quickly. Here's what that would look like. So I've got two switches right here. You can see blank configurations. Let's get into global config. I'll say, we'll put the host name on this guy first. This is DLS W01. Say no IP domain lookup for any typos. And all I'm going to do is I'm going to go into interface fast Ethernet 101, and I'm going to say switch port mode trunk. And then there's that error, right? So again, this is a 3750 switch, and we see that error because we're currently set up on this port. Do show interface fast Ethernet 101 switch port. This interface is currently set up to negotiate the trunking protocol, or trunking encapsulation protocol, right? And so this again is why you get this error on multi-layer switches, and specifically multi-layer switches that support ISL and have dynamic auto, which means the administrative trunking encapsulation is we are going to try to negotiate that. And so this is the process we talked about earlier, is you plug the two switches in, it's dynamic auto, it's going to try to negotiate the trunking protocol. So it tries to negotiate ISL, and that's going to fail. It because it's dynamic auto on both sides, right? Remember, it's got to be auto desirable, auto something other than auto on both ends. Because if they're both auto, it's not going to negotiate a trunk. It's going to negotiate a static access. but it tries to negotiate ISL. It tries to negotiate 802.1q. So when I say switch port mode trunk, what's happening is I am hard coding this port to be a trunk port. In other words, I don't want any negotiation taking place, but that's exactly what dynamic auto is set to do for the trunking encapsulation. And so here it says an interface whose trunk encapsulation is auto, it's going to try to negotiate. And so you can't configure that to trunk mode, meaning trunk mode on with the switch port mode trunk command. Because that command is telling the port, hey, I'm hard coding you as a trunk port, you can no longer negotiate. And it says, well, we've got a problem then because I'm currently configured to do negotiation here. So you're going to have to change my trunking encapsulation so that I am no longer trying to negotiate that before you say switch port mode trunk. And so think of it as being mutually exclusive, right? I can't turn it on if the port is also thinking it's going to be negotiating what the encapsulation is. So in order for me to turn this into a trunk port, hard code it with switch port mode trunk and put it into the on trunking mode, I have to first also hard code the trunking encapsulation so that it doesn't think it's supposed to try to negotiate things. And so we'll say switch port trunk encap.1q or just switch port TED. That's all you need. And now I can come back and say switch port MT, right? Switch port mode trunk. And you can see that this has come to up. But now what happens if I were to say on this port, and this is plugged in to what I believe is another switch, and we're going to find out right now. Spanning tree, Bpdu Guard, enable. So I just turned Bpdu Guard on and take a look at what happens. And this is exactly what we want. So maybe you've got a junior SA, a junior network administrator who mistakenly brings the port up, something goes wrong, but you want to protect yourself from what could be an environment-wide outage, right? Due to some sort of a broadcast storm, okay? And Bpdu Guard is going to do this. So it says PM4, right? Port manager is the facility. The severity level is 4 for warning. And then here's the mnemonic describing what's going on. Is we've got an error disabled. Bpdu Guard error detected on Fast Ethernet 101, putting Fast Ethernet 101 into the error disabled state, right? Because we put Bpdu Guard on there. Now it immediately changed the state to down. So in other words, it's not administratively shut down, right? Because administratively, did I go in here and say no shut? No. It's basically error disabled, which means no traffic is passing over this link, which is exactly what you want. Because obviously a mistake has happened here, and a device that sends BPDUs, right? You can see spanning tree block Bpdu Guard. We've got all kinds of issues. But it took the port down, and it did it immediately upon reception of the initial Bpdu. And that is Bpdu Guard, right? Because if you're not expecting a Bpdu speaking device, i.e. a switch, to be plugged in to that port, then simply put Bpdu Guard on there to protect yourself from that. Because it's even worse that, you know, if we didn't do that and we had portfast on and someone plugged in a switch, you'd be in all kinds of trouble. All right. So we assigned the VLANs, or we did Fast Ethernet 06. Let's get into Fast Ethernet 018. And again, switch port mode access, switch port access, VLAN 20. And then I'll say spanning tree portfast because we know that's coming. And then I'm going to say spanning tree Bpdu Guard enable. and then we'll go into interface fast Ethernet 011, and then we'll say switch port mode trunk. I'm sorry, switch port mode access, switch port access VLAN 10, and then spanning tree portfast, spanning tree Bpdu Guard enable, and then we'll do a quick do show run. And I'm actually hoping that on the last port we did it keep it in there? No, it didn't. Or 11 was what I was looking for. No, okay. So yeah. So now we're properly configured on all of our access ports. So verify the VLANs. Well, let's say do show VLAN brief, and they give us the command there, right? And we can see 10, 20, 30, 40, 50, 60, 70, 80, 99. So now here is where we're going to be changing things. Now, before we do this, if I say do show span, right, you can see that it tells us that the spanning tree, tells us the spanning tree protocol is IEEE. And it tells us when we say do show span summary, it shows us that the mode is PVST, right, which was based on the original 802.1d standard. But remember, as of 2004, that is, the original spanning tree protocol is no longer in that 802.1d definition, right? And it's not in the standard anymore. And so here's what becomes confusing for a lot of learners is you get this output here and you look and you say, oh, hey, it's an alternate port. Well, I know that alternate ports are only seen, and we'll talk about the different types of ports, right? Or the different, it's not the port role, it's, yeah, port type. I will leave it at port type, right? The different port types, which are different from the roles, right? So you see this, and I think I've got that backwards. Or no, I don't have that backwards. So you see it here. It says, what's the role? It says it's an alternate port. And you think immediately, oh, well, alternate ports, you can only have those when we're talking about rapid spanning tree protocol, right? Because remember, it was a non-designated port with the legacy standard. But it's been different since 2004. And so in Cisco's code, even when you're running the IEEE protocol, right, or I should say the Cisco's adaptation of the original 802.1d standard, right, and even though you see up here, right, or if I were to say do show spanning tree summary, even though you see that the switch is in PVST mode, which we know is based off of the original standard, Cisco has basically made the assumption that you're probably not going to be running the legacy standard. You shouldn't be running the legacy implementation, Cisco's legacy implementation, PVST, because again, the new RPVST Plus, that is backwards compatible. It'll work, right? It'll work with this legacy implementation, the PVST or PVST Plus. So even when you see that, do show span, it's just that they put this in here because that's what the role, right? Or that's what the, and I hate to say, yeah, I think I got it backwards. I apologize. I was looking right at it and it's saying role. So that's the role, not the state, right? The state would be that disabled blocking, listening, learning, forwarding, or with the rapid spanning tree protocol, discarding, learning, and forwarding. So, and then the role is an alternate port. And so, in other words, that would be an alternate port, right? Even though the concept of the alternate port is a rapid spanning tree protocol concept, and with Cisco, the rapid per VLAN spanning tree plus. All right, so we've got that knocked out. Let's go ahead and get our trunks set up. Assign the trunks to native VLAN 99. And so we're going to be doing this on all 4 switches. So again, that interface range command becomes very important. Interface range, fast Ethernet 0/124. And it wants us to configure them as trunk ports. So we're going to say switch port mode trunk. I'm also going to say switch port no negotiate. Best practice, right? I don't want it trying to negotiate because I'm hard coding it as a trunk port. Switch port trunk native VLAN 99. And we're going to repeat that on switch 3. And again, we're in user exec here. So enable privilege exec conf T to get the global config, interface range, fast Ethernet 01-4, switch port mode trunk, switch port non for no negotiate, and then we were going to do switch port trunk native VLAN 99. And again, remember that native VLAN 99 is for frames that are received on the switch over the trunk link that do not have a VLAN tag. Okay, switch 1, same thing. User exec, privilege exec, conf T to get the global config, interface range, fast Ethernet 01-4, and we are switch port mode trunk, and we are switch port no negotiate, and then switch port trunk VLAN native, switch port trunk native VLAN 99. All right, and so our consistencies have been resolved all the way around. So now here's where we get into configuring rapid spanning tree PVST plus load balancing. And the concept is identical. And that's one of the nice things about the transition from legacy PVST plus to RPVST plus, right? Is that the commands that we're using to make these configuration changes, doing this layer 2 traffic engineering, the load balancing of the VLANs across these inner switch links, right? So some of the VLANs will go this way, their traffic will go that way, and then others are going to go that way, right? And again, I really like how they laid this out here, as this is kind of, distro 1, and this is distribution layer switch 2, and maybe this is access layer switch 1, to where we're now going to be setting up this load balancing, right? So let's pull that back, and let me take a quick look here. And we are... Okay, so yeah, I'm sorry, I was reading this part 2 right in here, but there are no instructions there. So we're going to be changing the spanning tree mode, right? Remember, it's backward compatible, right? RPVST and RPVST plus are backward compatible with PVST and PVST plus. So how do we change the mode? Well, it's very straightforward. It's spanning tree mode, and if I do a question mark here, you can see we've got two choices, either PVST or rapid PVST. So we change it to rapid PVST. And let's walk around. And actually, before we do that, you can see right here, configure switch 1 to be the primary route for VLANs 1, 10, 30, 50, and 70. So the VLANs that have an odd number as the first digit. Make sure I say that right this time. So spanning tree VLAN 1, 10, 30, 50, 70, making sure we get this right here. And we're basically going to say root primary. Now remember, when we do this, switch 1 is going to be, we're going to be looking at BPDUs to see what the current bridge priority is for those VLANs. And we're going to drop ourselves down. This is a macro that's running right now. So we're going to be dropping ourselves down to one of the accepted values. And remember, if you can't remember the values, which I consistently do not off the top of my head, all you would have to do is say spanning tree VLAN 1 priority and then put a bogus value in, and it'll show you the values. And so it's going to drop it to 24576, right? Sort of a, it's a nice halfway point here, and it's going to drop the bridge priority for switch 1 for those specific VLANs only to 24576, because that is good enough, right? It's 2 increments down from the default of 32768. So we drop it 4096 to 28672, and then we drop it another 4096. We bring it down here to 24576. So it drops it just enough so that for this root bridge, switch 1, it's going to be the root bridge for those individual VLANs that we identified on the command line, right? In fact, if I come over to switch 3 right now, and I were to say do show span, right? When we take a look, you can see what is the root ID priority. Remember, we've got that system ID extension, which is nothing more than the VLAN number that gets added in to the bridge priority, because this information at the top here of the output, that is for the root bridge. This information here is for the bridge that we are on. In other words, the switch, and those are, I'll use those as synonymous terms, although yes, there is a technical difference. Bridges are legacy. You're probably never going to see a bridge ever again, but the terminology is still here, bridge ID. So we'll use it as synonymous, knowing that there are technical differences. Bridges are done in software, or were done in software, and the switches are using hardware, right? So here is the root bridge information, right? I've got my cost to the root bridge is 19. I've got port fast Ethernet 01. That is the port out which here on switch 3 that I would use. And the reason is because this guy right here is clearly blocking, because we would have a loop right there if one of these two links was not blocking. And then you can see the Bpdu hello time of 2 seconds. We've got our max age and our forward delay, which is at 15 seconds that we're going to be waiting. So here's the information, and you can see it still shows the protocols IEEE. We haven't changed it on this side yet, right? We haven't made that change yet. So we've taken care of switch 1. We're on switch 3, and switch 3 is next up. So let's go ahead and say spanning tree mode rapid PVST, right? And you can see what happens when we change the mode. Spanning tree needs to reconverge, right? And so that reconvergence is taking place right now. And then for switch 3, it's going to be spanning tree VLAN 20, 40, 60, 80, and 99. And we're going to say root, and it's supposed to be the primary for those VLANs. I was about to say the ones that have even numbers for the first digit, but 99 kind of blows that up. So we've got that in there now, right? So it's properly configured here. So let's go ahead and say show spanning tree now, right? And you can see the information up here on the top is very, very similar, but spanning tree protocol enable is not, or the enabled protocol, it says RSTP, which, remember, Cisco's implementation of that is RPVST plus, because we're going from here forward, we're going to say there is no ISL that's going to be in the environment. So RPVST plus, rapid per VLAN spanning tree. And so now we see that there's been a change. Okay, and actually we were still, looks like in the, it looks like it left it in the learning, right? And now is probably a good time to talk about the port states, right? I apologize for the confusion earlier, right? So the port states in RSTP or RPVST plus, right? The port states are the following. You've got discarding, which means, and this is a very important differentiation, means no data frames, right? It's not control plane frames, it's data plane frames. So if you're running dynamic trunking protocol, or you're running LACP for ether channel, to do in ether channel, or PAGP or VLAN trunking protocol, all of those frames go across a discarding port. Those are still being received and processed. It's the data frames, right? So, you know, PC3 tries to send something out to the internet, and it hits a discard, and there's a discarding port. It's the traffic. That traffic is not going to make it. But all of the control plane traffic for, you know, dynamic trunking protocol, Cisco Discovery Protocol is another one, PAGP, LACP, all of those control plane layer 2 frames are going to be received. That traffic is going to be sent and received. So let me take that off there real quick. All right, so then the final thing we need to do is switch 2 is going to be the secondary root bridge for everybody. So we're going to say spanning tree VLAN 1, 10, 20, 30, 40, 50, 60, 70, 80, and 99. And I think I need to put management IP addresses. Yeah, the management interface. I'll step back to that. So, and what are we going to say? Root secondary. So what happens here? Again, this is a macro. Remember, nowhere do you see me typing in spanning tree VLAN, listing the VLANs out and saying priority, and if we pull back, priority 28672. You don't see me typing that in. But switch 2 sees the root bridge priority for all of the VLANs I'm getting ready to make the change on switch 2 for, and says, well, that is the primary bridge priority right now, so I'm just going to bump it above that for the VLANs in question. So I don't say priority 28672. I don't say priority 28672 here. I just simply say root secondary, and it's smart enough to check the BPDUs that it has received for these VLANs for which it's about to become secondary, and it says, okay, yeah, well, I see that it's 24576, so I'm just going to bump that up by 4096, and now I'm higher than the root bridge for all of those VLANs. Therefore, I am what we're going to refer to here as the secondary root bridge, right? So that takes care of that configuration. Now I overlooked, let me get into interface VLAN 99. We need to be configuring here some management interfaces. And so let's go IP address 172.17.99. And this is going to be switch 2 is 12/24, right? And let's come back to switch 1. And we're going to say interface VLAN 99. IP address is 172.17.99.11. And then this is a /24, 255.0. And then we will go to, I think we're just on switch 2. Switch 1. Yeah, sorry, we did switch 1. Switch 3. So we'll come over to switch 3 here. And interface, well, first in the global config with the conft configure terminal. Interface VLAN 99. IP address 172.17.99 dot, and for switch 3, it's going to be 13. And again, a /24. All right, so we've got that knocked out. So that brings us down to, I believe that is the, yeah, so we're at 99 out of 100, and it wants us to basically configure, I'm sorry, to confirm that we've got connectivity here. So if I was to say ping 172.17.99.11, and we'll say do ping, and we should have connectivity to 99.11, and we do, and then 99.12, which is switch 2, and we've got connectivity there. So we have connectivity across all of the switches. And there is something that is missing. I'm sure that I read right by one of the instructions here. And so in the effort to save a little time here, let's see where we've got the one. Oh, there it is. And oh, wow. So it looks like I forgot to configure on switch 2 the mode for spanning tree. So we'll come back on here and we'll say spanning tree, or actually, yeah, that's right, I did forget. I did the VLANs. I was just looking up here. I was like, I swear I thought we did that. So I did the VLANs. So spanning tree mode, rapid PVST. Now, I want to talk very briefly here about not just the differences in the port states and the port roles, but the logical question when you get told, hey, you know, rapid spanning tree is rapid. It's faster than PVST and PVST plus, right? So why is it that RPVST plus can converge quicker, right? What is happening there? So, and what happens is it's called proposal and agreement, right? It's sort of, sometimes you'll hear it referred to as a dispute mechanism. And this is where the alternate port concept comes into play. So you can see here, and actually let me, if I pull switch 1 up real quick, let's get a look here, and we'll just pick one of the VLANs. Do show spanning tree. And so we can see that for VLAN 1 on switch 1, right, so here's VLAN 1. This is switch 1. Here is my alternate port. It says that for VLAN 1, my alternate port is fast Ethernet 02, which is that port right there. That's the alternate port. And so this is the difference between legacy PVST plus and RPVST plus. The difference is that this alternate port, you can think of it as that the spanning tree topology has converged, and switch 1 knows right now that if for whatever reason their root port, and actually this is probably not a good example because switch 1 is the root bridge, so apologies. The conversation is going to be the same, but let's go to VLAN 20. And as soon as I said root port, I looked, and of course, right, remember, the root bridge has no root ports for the VLANs for which it's responsible as a root bridge. However, here, VLAN 20, let's say, what's our alternate port? Well, we've got 3 alternate ports, right? The root port is that port right there. There's my root port, right? Because I am not the root bridge, so we know that switch 3 is the root bridge for VLAN 20. So this is the root port because it is the closest port. And so let me ask you this. These are individual trunk links here. So how does the election of the ports go, right? So again, we take it back. Switch 1 and switch 3, okay, for VLAN 20. What's the first thing they look at? They look at the bridge ID. And remember, the bridge ID is, and actually if I go back to this here real quick, the bridge ID, okay, the bridge ID, it's all about the priority, the system ID extension, which is just the VLAN number, and then the MAC address. So we made those changes to switch 3 down here, and we said, hey, you're the root bridge. You're going to be for VLAN 20, 24576 is your priority value, right? For switch 1, we left it as the default, that 32768. And so the BPDUs go back and forth here between switch 1 and switch 3 for VLAN 20, we'll say when they first come up, and they're trying to determine who's the root bridge. Well, switch 1 says, hey, I'm the root bridge. And then switch 3 says, hey, I'm the root bridge. They look at the BPDU and the values in the BPDU fields, and this is a no-brainer. 24576, because we did the configuration on switch 3, is lower than 32768. So now it does it for both of these links. However, we've got a loop here with respect to VLAN 20. So one of these ports is going to have to be a blocking port. And when I say one of these ports, it's going to be either fast Ethernet 01 or 02. And so that's where it comes down to the fact that the root port is going to be the one selected based off the sender's bridge ID, right? But we've got 2 links that are going to get the same sender's bridge ID. Then we have to look at the sender's port ID, right? That port ID output that you see when you say do show span, or the priority, I should say the port priority. And again, it's the sender's port priority. So what happened here between FA01 and 02? The priorities came in. The bridge ID was the same because it's coming from the same switch. But when we look at the priority numbers, remember, in spanning tree, lower is always better and will always win out. And right here, 128.1 is lower than 128.2. And so that is why this becomes the root port, fast Ethernet 01. But Rapid Spanning Tree Protocol, or RPVST Plus, is smart enough to know, hey, yeah, well, I have 2 links going over there, so you know what I'm going to do? I'm going to say that that is my alternate here, right? And I know right now that if this link goes down, I am going to bring this guy, I'm going to transition him from a blocking state, that BLK right there, I'm going to transition him from a blocking state to a forwarding state, right? That's my backup. And the analogy that you can think of here is the Eigrp topology table. And I know we haven't spoken about feasible successors yet, but Eigrp does the same thing. If it has multiple paths to a destination network, and if the secondary path can be shown, mathematically proven to be loop-free, when it's initially trying to figure things out, it keeps it in the topology table for that very moment when when the successor route, for whatever reason, right, goes away, it immediately installs that backup into the RIB, the routing information base, the routing table, and it knows it's mathematically loop-free. And so it can quickly simply insert it. It doesn't have to reconverge fully and go through the diffusing update algorithm to try to figure out, oh my goodness, is this loop-free? No. It already knows that. So think of it as a standby, right? It keeps it as a standby that in the event that that link goes down right there, boom, all my traffic is going to come across this link right here. And that's why you see the role as alternate. You see it's blocking, and then we see our cost to get to the root bridge, right? And then you've got fast Ethernet 03 and 04 for VLAN 20. And here's a question for you. So why are they listed as alternates going through fast Ethernet 03 and 04 for VLAN 20? Why is that? Why is this also an alternate path, but only with the cost of 19? Yeah, remember the secondary root bridge, right? We made switch 2 the secondary root bridge. And so it too has a lower priority than switch 3. But in terms of cost, would that be correct? Because to go out this link here, it's going to be 19, and then to get to that root bridge, it's going to be another 19, right? So again, and I've got a video somewhere on my site about, especially with Ether channel, when you start doing Ether channel, the costing gets a little convoluted. It's not correct. It's not what you would see on a regular switch. And so again, fast Ethernet 03 and 4, which are these two links right here, right? That is an alternate path that they can go, okay? All right, so this is going to wrap up Packet Tracer Activity 3.3.2.2. And again, to clarify one more time, port states in rapid spanning tree, discarding, learning, forwarding. There's only 3. There's no longer 5, right? If we talk about the port roles, you've got the alternate port that we talked about. You've got the backup port, and you'll hear that term come up sometimes, the backup port. Remember, that is the role of a port that is in a hub, and chances are you're not going to run into that backup port status, right? Or I should say port role. I need to make sure I say this correctly. You're not going to run into the backup port role unless you've got your switches with multiple connections running into a hub. Then we've got the designated port, right? And it's the exact same thing, right? It's the downward facing port. Every port on the root bridge for the VLAN in question is a designated port. And then you've got your root port. And remember, the root bridge has no root ports for the VLAN for which it is the root bridge. Because remember, you can see here, you can see here, well, hey, wait a second. Why is there a root port on switch 1? Because it's a root bridge. Right, but remember, is it the root bridge for VLAN 20? And the answer to that is no. And so the root port is the port on the non-root bridge for the VLAN we're talking about. It's the closest port on that non-root bridge. Okay, so those are the states, right? Those are the port states. Those are the port roles. We talked about the backup and we talked about the alternate, right? And real quick, the chapter mentioned it. So port, and what's the, I keep the state role port. I always forget, port type, sorry, port type, there it is. You've got there's two port types, a point-to-point link, right? And that's when you've got switches connected to each other, and then a shared link. So in other words, a shared link is when the switches go into a shared medium, a half duplex medium like a hub. But again, chances are you're not going to run into hubs in today's modern networking environments. All right, well, thank you guys so much for watching. There's going to be one more spanning tree video. It's going to be sort of a supplement to cover some of the other things in the chapter that were not covered in these videos that I've done right now so far. All right, enjoy the rest of your weekend, and I will see you on Tuesday evening.